Hello students, today we'll be talking about one of the important laws of electrostatic, which is your Coulomb's law. And in this law, he states that the electrostatic forces of attraction and repulsion between 2 point charges. So suppose if we consider two charges Q1 and Q2 and it's separated by a distance r, we know that these charges will be experiencing either an attractive force or repulsive force between them. So it will be experiencing a repulsive force when both of the charges are same in nature, and it will be experiencing an attractive force when the two charges, nature of the charges are opposite in nature, one being positive, the other being negative. So that being said, Coulomb here, he says that the electrostatic forces of attraction and repulsion between two charges is directly proportional to the product of the charges and inversely proportional to the square of the distance of separation between them, which means that the force here is directly proportional to the product of the two charges. As the charge value increases, the force will also increase. If the charge value decreases, the force will eventually decrease. Likewise, force is also inversely proportional to the square of the distance between them, which means that with the increase in distance between the two charge, they will be experiencing lesser attraction or repulsion between them, as compared to when the charges are kept close to each other, they will be experiencing a strong attraction and repulsion. And if we increase the distance between them, it will be experiencing a force, a repulsive and an attractive force, which is lesser. So that being said, when we combine equation number 1 and equation number 2, we get F is directly proportional to Q1, Q2 by R square. Since we can see our proportionality sign here, when we remove this, we'll be getting a constant K. So here, K, it is your electrostatic force constant, and its value is 1 by 4 pi epsilon naught. Here epsilon naught, it is the permittivity of free space, whose value is 8.854 into 10 to the power minus 12 Coulomb square Newton inverse meter square inverse. Now, since we already know the value of K, we'll be substituting that value here, which will give us F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Since we know, so this is our equation of this is the equation given to us by Coulomb's law. Likewise, if we see here the value of K, we know that 4 is constant, pi is constant, and we also know the value of epsilon naught. So when we substitute this and simplify it, we will get a value of K, the value of 1 by 4 pi epsilon naught, to be 9 into 10 to the power 9. So this is the law of Coulomb, which is given to us. Now if we consider Q1 and Q2 to be 1 Coulomb, R to be 1 meter, and the value of 1 by 4 pi, which we found out to be 9 into 10 to the power 9. So when we substitute all these values in this equation, F is equal to 9 into 10 to the power 9. Q charges are, the charge of Q is 1 Coulomb, and the distance between them is 1 meter. So when you solve this out, you get a force value to be 9 into 10 to the power Newton, which is exactly the definition of 1 Coulomb. So 1 Coulomb is a charge that produces a force of 9 into 10 to the power Newton on an equal charge 1 meter apart in vacuum, when the distance is 1 meter apart. That is how we can define 1 Coulomb. Now, using the final equation of Coulomb's law, F is equal to K, Q1, Q2 by R square, we can find out the unit of K. So keeping K on one side, we have F R square Q1 by Q2. We know that the SI unit of force is Newton, the SI unit of distance is meter square. Since there is two charges, Coulomb into Coulomb will give me Coulomb square. So from here, if we send Coulomb square to the numerator, it will become N Newton meter square Coulomb square inverse. So the unit of K is equal to 9 into 10 to the power 9 Newton meter square Coulomb square inverse. Likewise, there are also some limitations of Coulomb's law. So this Coulomb's law can be applicable only for static charges, which means the charges which are at rest. Likewise, this Coulomb's law is applicable only for point charges which are very small in size. Likewise, the separation between the two charges should not be very large. If the separation between the two charges is very large, the forces of attraction and repulsion will also be very small, and that's how Coulomb's law will not be applicable for this type of relation.